It sits on the flight deck of the USS George HW Bush, a single unmarked shipping container. No barrel, no turret, no antenna visible on the outside. The flight crew walks past it every single day. Most of them have no idea what it does. Here is what it does. It fires a beam of light at the speed of 186,000 miles per second. It locks onto a drone hurtling toward the ship at 150 miles per hour. It holds that beam on one spot the size of a quarter, and within 2 to 5 seconds, the drone stops flying. Cost per shot? $1. Not 1,000, not 100. $1. The price of the electricity it takes to pull the trigger. Now consider what that container is sitting next to. A nuclear-powered aircraft carrier worth $6 billion, escorted by destroyers carrying interceptor missiles that cost $1.5 million each. A strike group engineered to project American power across any ocean on Earth. And the single biggest threat to all of it right now is not a foreign destroyer. It is not a hypersonic missile. It is a drone that costs $20,000 and is built from fiberglass. This is Daily War Machine. We do not cover weapons, we cover what makes them necessary. And today, we are going inside the math that nearly broke the carrier strike group, and the $1 answer the Navy bolted to a flight deck to fix it. Type SHIELD in the comments if by the end you think it works. To understand why that container matters, you have to understand the trap the Navy walked into. For decades, the United States Navy built its entire defensive doctrine around one assumption: the enemy sends expensive threats. You intercept them with expensive weapons. The math works because both sides are spending roughly the same. A carrier strike group is the masterpiece of that doctrine. The Ticonderoga-class cruiser carries 122 vertical launch cells. The Arleigh Burke destroyer carries 96. Every cell loaded with interceptors engineered for precision, for speed, for lethality at ranges beyond the horizon. The doctrine assumes the enemy sends a small number of high-value threats: a cruise missile, an anti-ship ballistic missile, something expensive enough to justify firing $1 million interceptor at it. Then the cheap drone arrived, and it broke everything. Because the drone does not care about your radar range. It does not care about your Aegis combat system. It does not care about your $1.5 million evolved Sea Sparrow missile. It only cares about one number. How many interceptors do you have in those tubes? Iran understood this before most Western analysts did. When the USS Bruins intercepted the Iranian-flagged MV Tuska on April 19, 2026, Tehran did not respond with warships. It did not scramble fighter jets. It launched waves of one-way attack drones, cheap, expendable, fiberglass airframes loaded with small warheads. The scenario carrier planners had been wargaming for a decade was now unfolding in real time. And the message was not subtle. We cannot match your warships ship for ship, but we can drown them in numbers. Let us look at the equation that makes this terrifying. The ESSM, the Evolved Sea Sparrow missile, is one of the finest interceptors ever built. It travels at Mach 4. It pulls 50 Gs in a turn. It almost never misses. It costs $1.5 million per shot. The drone it is shooting down costs $20,000 to build. That is a 75-to-1 financial loss on every single intercept. The intercept is perfect. The economics are a disaster. Think about it this way. Imagine fighting off a swarm of bees using a gold-plated sniper rifle. Every time you pull the trigger, you kill exactly one bee, but you will run out of bullets long before that hive runs out of bees. Now scale that up. A carrier strike group has a finite number of VLS cells. Every destroyer, every cruiser, every escort ship shares one collective magazine. If the enemy launches more drones than you have interceptors, the math becomes inescapable. The 101st drone gets through. And here's the part that makes it worse. At sea, you cannot reload those cells. Underway replenishment of a vertical launch system is extraordinarily dangerous and essentially impossible in a combat zone. Once those tubes are empty, the entire formation is defenseless. The carrier does not get sunk. The carrier gets forced to turn around, to abandon its strategic position, to sail the entire group home and rearm. The deterrence effect of a $6 billion nuclear-powered strike group does not crumble because an adversary pierced the armor. It crumbles because an adversary emptied the wallet. That is the trap. Not a weapons problem, a math problem. And the Navy needed an answer that operated outside that math entirely. Normally, adding a new weapon system to an aircraft carrier is a years-long process. When the Navy integrated the ANPY-6 radar onto Flight 3 Burke destroyers, it required a complete hull redesign, years of structural engineering, billions in shipyard contracts. For a carrier, the process is even more demanding. The George HW Bush was commissioned in 2009. Its midlife refueling and complex overhaul is not scheduled until the early 2030s. There is no dry dock window. There is no time to cut open the hull, run new wiring, redesign the cooling systems, rewrite the combat software from scratch. But the drones were already here. So the Navy did something it had never done before on a carrier. It palletized the weapon. The containerized LOCUST Laser Weapon System, developed by AeroVironment under a modular open systems architecture, is a self-contained directed energy unit. No hull modification, no dry dock. They dropped the container onto the flight deck of CV-77, connected power cables to the ship's existing electrical grid, and within days, not years, the carrier had a functioning laser weapon. Now, directed energy systems on warships are not new. The laser weapon system on USS Ponce, the Helios system on USS Preble. Both tested, both proven. But those ships run on conventional engines. Their electrical output has a hard ceiling, which means their laser has a hard ceiling. What happened on CV-77 was fundamentally different. The Nimitz-class carrier is powered by two A4W nuclear reactors. Those reactors produce electrical power on a scale no conventional warship can approach. By connecting the LOCUST system to that grid, the Navy did not just give the carrier a laser, it turned the carrier's nuclear plant into an ammunition factory that never shuts down. Cost per shot? $1. The price of electricity. The 75-to-1 financial disadvantage just became a 20,000-to-1 advantage. Here is where the Hollywood version needs to be corrected. A laser does not blow a drone out of the sky. There is no explosion, no fireball, no Hollywood detonation. A laser kills through thermal load. It focuses an infrared beam onto a surface area the size of a quarter. It holds that beam on one point for 2 to 5 seconds. This is called dwell time. During that dwell time, the beam is not blasting through anything. It is heating, precisely, continuously. The wing joint warps, the battery casing melts, the thin fiberglass shell buckles and loses its aerodynamic shape. The drone does not explode. It loses lift. It spirals. It hits the water. No shrapnel raining onto the flight deck, no brass casings from a phalanx CIWS bouncing into a jet engine intake, no smoke trail advertising the carrier's position to every sensor in the area. The flight deck stays clean. The jets keep launching. The carrier fights through the attack without pausing flight operations for a single minute. But the limitations matter just as much as the capabilities, and understanding them is what separates analysis from marketing. A 20 to 35 kilowatt laser burns through fiberglass. It does not burn through the hardened steel casing of a hypersonic cruise missile. It does not stop a supersonic anti-ship ballistic missile diving at Mach 5. Heavy rain degrades it. Dense fog scatters the beam. High seas kick up salt spray that absorbs photons at range. The LOCUST is not an all-weather, all-threat silver bullet. It is a precision tool designed for one specific layer of the defense. And that layer is the only one that was broken. Pull back from the hardware for a moment and look at what this container actually does to the strike group's architecture. Before LOCUST, every threat, a $20,000 fiberglass drone and a $10 million hypersonic missile, drew from the same finite pool of interceptors. The Aegis system could not afford to distinguish between a nuisance and an existential threat at the point of expenditure. It had to fire the same million-dollar missile at both. The laser does not make the ship more powerful. It makes the ship more intelligent about what it chooses to spend its irreplaceable kinetic ammunition on. With LOCUST handling the bottom layer, the ESSM stays in the tube. The ram missile stays on the rail. Every expensive interceptor is preserved, locked and loaded, waiting for the one threat that actually demands a kinetic response. The carrier's nuclear plant stops being just a propulsion system. It becomes the defensive shield that protects the missile inventory from being bled dry by $20,000 drones. In October 2025, the LOCUST system aboard CVN-77 locked onto multiple incoming UAVs during live testing and burned them down one after another in rapid succession. The physics of carrier defense had changed, not because the laser could do everything, because it could do the one thing the missiles could not afford to keep doing. So here is the equation that shipping container actually solves. The problem was never the accuracy of the interceptor. The interceptor was perfect. The problem was that perfection was being spent on targets that did not deserve it. A $1.5 million missile killing a $20,000 drone is not a defensive victory. It is a slow financial defeat disguised as one. The LOCUST laser does not replace the missile. It protects the missile from being wasted. And in doing that, in separating the cheap threats from the expensive ones, it may have answered the most dangerous question in modern naval warfare. How do you defend a $6 billion warship against an enemy whose entire attack costs less than a civilian car? You stop using a gold-plated sniper rifle to kill bees. You plug a $1 beam of light into a nuclear reactor, and you let physics do what economics could not. The question that remains is bigger than this carrier. If a shipping container on a flight deck can rewrite the economics of naval defense, what does that mean for the next swarm? Not 20 drones, not 50. What happens when the number is 500? Subscribe to Daily War Machine. We do not cover hardware. We cover what makes it possible and what it cannot survive. Drop SHIELD in the comments if the math holds. The next equation is already being built.